All right, let's see about getting the next topic done, which is understanding numbers of different bases. All right, that's the topic that we're going to do. And this is just simply about working in different bases. So we usually use the decimal system. And what we're going to do now is we're going to talk about the other base numbers like base 2 number system or the binary number system, the quaternary number system, and the octal number systems such as that. So the objective is to state the value of a digit of a numeral in a given base. All right, so let's first start off with a few definitions. And change this to blue, and we'll start off with a few definitions that you should already know, but just to make sure that you don't have any confusions about it, we'll do it over anyway. So let's see, just put this over here, and I'll just say that this is going to be some definitions. And the first definition that we're going to look at is face value. I think I can put this in a different color and put this in this color here. Nope, put this in this color here. Definition. So, right, backspace, and then the first one that we're going to look at is the one called face value. Now, as I said, you already know this, so if it is that you think you know it, you don't have to stick around. All right. So the face value, it is the value of the digit itself, irrespective of its position in the numeral. And let me give you an example of that. So, example, in the number 564, we can say that 5 has face value of 5. 6 has face value of 6. And obviously 4 has face value of 4, right? Next, we want to talk about something called the place value, and this is probably what you mix up. If it is that you think I was doing this like I'm crazy, this is probably what you mix up with this. So this is place value, and the place value, let me just put this white. It is the value a digit has depending on its position in the numeral, right? It is the face value multiplied by base raised to the power of its position. Basically, we're going to talk about counting from right to left, starting at 0. Alright, and I'm just going to highlight that key statement there so you can understand it a little bit better. I'm going to put it in orange maybe. Yeah, orange is going to be a good color. Alright, starting from right, counting from right to left, starting at 0. Right? Now, we usually operate in the base 10 number system or the decimal number system, so we put a definition for that as well. Right here, so base 10 or the decimal system is the one, as I said, keep saying, repeating, we work in this. So in the decimal system, base 10, each digit's place value is calculated as the digit times 10 raised to the power of its position, right? And this is an example of that, and you probably understand it already. As I said, you already did this in primary school. So consider the number 3, 4, 5 in base 10. Right, so consider 3, 4, 5 in the base 10 number system. So if we have 3, 4, and 5, each one of these has their own unique thing. So like this one here has a base value of 3, a position of 2, and a place value of 3 times 10 to the second power, which is equal to 300, right? Again, let's do this one. So 4 has a face value of 4, a position of 1, and a place value of 4 times 10 to the power of 1, which is 40. And the 5, which is this one over here, has a face value of 5, a position of 0, a place value of, I'm going to write that here, 5 times 10 to the 0 power, which is equal to 5. And this gives us the value 345 here, right? Now, we're going to take this exact same principle right here, this exact same principle, and apply it to every other number system. So we're going to be using the face value and the place value for the different number systems so that you can interpret these numbers coming from different bases. And let's start off with the first base, which is base 2, the one that you would use for computers. Let me just find out the color that I'm using. So yellow for that. So I'm going to put this here and put this here, and I'm going to be talking about the base 2. Put it in yellow, right? So base 2, or the binary system. Again, this is something that you would use in computers. So you're gonna encounter this a lot if you do anything in relation to IT later on. In the current IT syllabus, it's not going to have this appearing much, right? Let me just put a little note about this one. So in the binary system, or the base 2, each digit's place, I should say, value is calculated as the digit times 2 raised to the power of its position. Right? So notice it's the exact same thing as we did before. It's just that instead of raising 10 to the power of whatever, we're going to raise 2 to the power of whatever, because we are using a base 2 number system. So let's do an example quickly. So example, let's say consider the number 1011 in base 2. So we have 1011 in the base 2 number system. Let's go ahead and look at the front digit right now. So we see in our face value of 1, we see in that it has a position, and I'm just going to write the position here. So the position goes, I should probably change the color of this, yeah, let's just use white here. So this here, so the position is 0, 1, 2, and then 3. So when we come, face value is there, and then position would be 3, and then place value would be 1 times 2 to the third power, which means we have 1 times 8, which means that we're going to have 8 in the base 10 number system. All right, so this digit alone represents 8. And if it is that I want to find out what the actual value of this entire binary number is, I just have to calculate this same place value for every single one of them. So I'll just put the place value for each of them. So for example, the place value of this one, that 0 is going to be 0 times 2 to the second. Let me put a different color here. The place value of this one is just going to be 1 times 2 to the 1, and then the place value of this one will just be 1 times 2 to the 0. And if I work out every single one of them, so like for example the one in yellow, it's going to be well, 0, 0, anything multiplied by 0 is 0, and then 2 to the 1 is 2 multiplied by 1, so this here is going to turn out to be 2. I should put an equal sign right here. I should put an equal sign right here. And then I have 2 to the power of 0. 2 to the power of 0 is 1. 1 times 1 is just going to be 1. So I'm going to have that there. And I just simply add these numbers together. So I'm going to add the 8, the 0, the 2, and then the 1. And I'm going to get 13 in the base 10 number system. Right? So now you see how you can go about taking any number from any other system and just simply converting it to a base 10. So we're going to do the same thing for the base 4 number system. Again, exact same thing as before. So let me just put this in here as quickly as possible. You can make a guess about it if you wish. So base 4, or the quaternary system. Right, so just take off that there, put this in yellow, and we're going to write. So in the quaternary system, or the base 4, each digit's place value is calculated as the digit times 4 raised to the power of its position. Right? Put that in white. And then put the next pencil. Example. Consider the number 132 in base 4. Right? Again, I'm just going to do only one position. I'm just going to choose one number out of it to do. So I'm going to say, okay, 1, 3, 2. I'm just going to identify what the value of 3 is, okay? Because I think you get the idea by now. So face value is 3. The position is 1. The place value is going to be 3 times 4 to the power of 1, which works out to be 12. And that's 12 in base 10 system. All right. I'm not going to bother to do the others and add them up so you can get the equivalent base 10 value for 132 in the base 4 system. You should usually put a little 4 down there to denote base 4 system and a little 2 down here to denote base 2 system. Right? That way you don't mix it up. If it is that it don't have anything written, it's base 10. Right, and then the last one I think we'll do is the octal, and yeah, I think you'll get the drift by then by the time I do the octal. So any other number system after that, you can figure it out on your own how to convert it back to decimal. So let me just do one more. So the octal, or what do you call it again? Base 8. You know what? Let me just follow the pattern I'm doing before. So base 8 octal system, right? And in this one, it's this exact same kind of note you want to have. So in the octal system or base 8 system, each digit place value is calculated as the digit times 8 raised to the power of its position. All right. Again, let's say an example, and this will be the last one. So example, consider the number 257 in base 8, and that is, well, let me just write that out and put the base value. So 257, 257, and well, let's look out 2. I'm going to use this one. So the face value is going to be 2. The position is going to be 2. The place value is going to be 2 times 8 to the second power. So we have 8 8 is 64. We're going to get 2 times 64, and 2 times 64 is 128. So that 2 there holds the value of 28 in the base 10 number system. In the base 10 system. Right? Now, one thing to note when you're looking at all these different base number systems, if you're doing base 8, the numbers will never go over 8. If you're doing base 4, the numbers will never go beyond 4. If you're doing base 2, it will never go beyond 2. So the digits that are visible in the base 10 system are usually 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right? Those are the 10 digits that we use in the decimal system. In the binary system, which is a 2-digit system, 0 and 1 is what we use. In the quaternary system, quaternary system, we're only going to have four numbers. So you're going to have 0, 1, 2, and 3. You're not going to go beyond that. Same thing for base 8. It's going to be 0, 1, 2, 3, 4, 5, 6, 7. That's it. All right. So now you know how to take any number from any of the other number systems and just simply find its original value in the base 10 number system. You figure out the place value of each of the digits, you add them up together, and it's giving you the base 10 equivalent. All right? Simple, simple. See you in the next one.